For years, using AI meant providing a specific prompt and waiting for a specific response. We're moving toward a system where you provide a broad goal and let the machine determine the steps required to achieve it. To understand the difference, look at the baseline. A standard chatbot is purely reactive. You ask a question, it gives an answer. The transaction ends there. Then we move to copilots. These sit alongside you in your workspace, helping you write an email or draft a function. But the human is still the one driving the process. This charts the leap to the AI agent. An agent takes a broad goal, plans the steps, and uses external tools. An AI writing code is a copilot. An AI deploying the server without human input, that is an agent. This shifts AI from a passive assistant into an independent actor. Productivity scales because the machine executes multi-step sequences in the background, rather than waiting for human input at every juncture. But the mechanics that make agents so powerful, unsupervised execution and deep system access, create a severe security liability. When a human-led system is breached, the damage is often limited by how fast the attacker can manually navigate. An autonomous agent operates at machine speed, meaning a single exploit can spread across your software stack before the first security alert even reaches a human operator. Imagine an agent managing your cloud storage. A threat actor hides a malicious instruction, a prompt injection, inside a seemingly normal document. As soon as the agent reads it, it executes the hidden command, autonomously exfiltrating or deleting your entire database in seconds. Protecting against this requires real organizational friction. You have to restrict permissions, build sandboxes, and force the agent to wait for human approvals. Maximizing an agent's independence increases the risk of a catastrophic compromise. Choosing how to deploy these tools means matching your tech stack to the level of risk you can afford. Let's look at the first deployment profile, the solo optimizer, an individual researcher or developer who needs high capability, low operating costs, and long-term efficiency. For this profile, the open-source Hermes framework has become a dominant choice, accumulating nearly 100,000 GitHub stars in just 7 weeks. This flowchart details why Hermes is growing so fast. It features a closed learning loop. When it successfully completes a complex task, the agent documents its process and saves it into persistent memory as a reusable skill. When faced with a similar request later, it bypasses the planning phase and executes the saved skill. This cuts research task time by 40%. The skills it learns are strictly domain-specific. A coding skill won't help it summarize an article. And its memory system is opaque, meaning you cannot easily audit exactly what data the agent has retained from your sessions. On security, Hermes restricts its ecosystem to 118 curated pre-scanned skills. By rejecting a massive open plugin architecture, it currently maintains 0 agent-specific security vulnerabilities. If you are willing to accept limited transparency and a narrow set of messaging integrations, Hermes provides compounding, machine-speed execution tailored for an individual.
The second profile is the collaborative team. These are small to medium businesses that need multi-user workflows and immediate connectivity across their existing tools. Here, OpenClaw is the market incumbent. It is built specifically for team deployment, featuring native integrations across 24 different messaging platforms. Its flexibility comes from its massive scale. Users have access to a library of over 13,000 community-submitted skills, allowing the agent to connect to almost any service imaginable. But that unvetted scale carries a severe consequence. In a single 4-day period, OpenClaw recorded 9 separate security vulnerabilities, including a critical CVSS 9.9 flaw. OpenClaw eliminates the friction of rolling out an agent to a large team, but it forces your organization to operate inside a highly vulnerable ecosystem that is not suited for sensitive data. Finally, we have the enterprise security leader. At this scale, a single automated error or breached credential threatens the entire organization. Many standard software environments operate on legacy, trust by default access. If you grant an autonomous agent broad permissions in this setup, a single compromised command can trigger cascading failures across your interconnected apps. This quadrant chart illustrates the required architectural shift. Moving away from high-risk default permissions requires heavy structural effort to implement agent identity governance. You have to treat AI agents exactly like privileged human employees.
That means issuing them separate SSO tokens, enforcing strict least privilege access, and continuously auditing their behavioral patterns. And over top of those identities, you must layer human-in-the-loop checkpoints. This causes the risk metric to plummet, but drastically increases operational friction. Every critical external action, whether that's sending an email batch or modifying code or transferring funds, stops and waits for manual human approval to prevent malicious prompt execution. Securing an enterprise environment means actively breaking the core promise of AI autonomy. The machine can only operate as fast as a human can approve its actions. The value of an autonomous agent is inversely proportional to how strictly you govern it. This matrix maps the approach to your risk profile. If you are a solo optimizer, deploy Hermes Agent. You benefit from its compounding memory and task efficiency. But you must restrict it to a local Docker sandbox, entirely isolated from your production API keys. For a collaborative team, OpenClaw provides the out-of-the-box convenience you need to connect your staff. But you must enforce a strict mandate against feeding it sensitive business data. And if you are managing enterprise infrastructure, avoid native open-source deployments completely. Wait until your team has architected an identity governance framework and human approval checkpoints. The right path isn't determined by which AI is the smartest. It is determined by the acceptable blast radius of your specific data environment. Optimize for your daily workflow, but architect systems for the worst-case scenario. An autonomous agent is only as safe as the cage around it.